topics. The first one is about the programming in general, what the programming is. Here I say that programming is giving life for a body. Without the software, the hardware is just a thing. Because some human bodies also look nice without software. If you have a computer without software, you cannot do anything with that computer. Or if you have a computer that is too old for any software, you cannot do anything useful for that. The computer has a software, then you can use that computer. But how to write that software? Software consists of at least one program. What is a program? Here my definition is that the program is an order of commands for reaching a goal. So, have you created some programs earlier in your life? And if you have not written a single program, you have created those programs in your head. You have thought of algorithms, how to perform some operations. Every program has to be written in a programming language. This is like you cannot talk to anybody without using a language for talking. Even animals use languages for talking to each other, for sending messages to each other. Think of some birds. They do like...
That's written.
Wait.
I try to do Morse code.
This is a word in Morse language. But there are languages everywhere. Some people who have investigated certain birds have found out that the structure of the sounds that they make repeats, and they also learn new combinations of them, and they understand each other. And even some plants forward information without talking. You can use, if you can, telepathy without talking, without writing, just exchange messages. This is like thought language. There must be a structure, a system. For thinking of an algorithm, you don't have to know any programming language. What is an algorithm? According to my definition here, an algorithm is such an order of commands that has a defined input and output. It is consistent, it is general, and it is final. What does it mean? So if you have an algorithm, it should work for any objects of a general type, and it should be final. But all the algorithms are not final. We have seen the example of the fridge. As long as the fridge is on, it just works and works, and it never ends working. So if you plan anything, you create an algorithm. If you plan a party, you create an algorithm for that party. If you want to send a message to another guy, first you think of that message. What should that message be? And then how to communicate that message. So for instance, the other guy is a French guy, knowing no words in the English language, no words in Estonian language. How would you forward that message to him so that he understands? You wouldn't talk to him, you would use another mean. What mean would you use? how to communicate him without using French, without using English, without using Estonian. For instance, yes. In dance, there are many combinations that you can repeat. Some animals dance, the swans dance, and every dance means something. Combination means something. Here is an example of how do I prepare my next school day. The input is a calendar, and the output is the plan for the next school day. And here is an activity diagram for that. And for the beginning, we use this dot here. Then the next one is a decision point. From one decision point, we can go to different branches. The first question is here. Do I have some teaching for tomorrow in my calendar? And there are two options, yes and no. Usually, every decision point is a yes-no question, because we always only have two choices. We always choose binary. So if we go the yes path along, then we meet the next decision point. And this is, do I remember what we did the last time and what was left for independent work? If I remember it, then am I prepared for tomorrow? If I am prepared, is there enough time for sleeping? At least 8 hours? If yes, then I finish. The algorithm is finished. The finish symbol is the dot that is surrounded by a circle, an empty circle. But we can also choose other paths. So for instance, if I can't remember what we did last time, then I have to look what I have reported. And then if I have not prepared anything, then I have to prepare first. And if there is not enough sleeping time, then I have to put an alarm. And if there is no teaching tomorrow, then I do not do any of these activities here. If I have at least 8 hours, then I do not need an alarm. I wake normally. This diagram is drawn using a language. And this language is called Unified Modeling Language, called shortly UML. UML we can use for any kind of modeling, and you have done it already for use cases and for activities. I have drawn this diagram using Draw.io, but there are other tools available for drawing UML diagrams. Every diagram can be written down as a pseudocode. What is a pseudocode? A pseudocode is like a program, but actually it is not a program, because you cannot feed it to any parser if it is not AlgoBox or something like that. The pseudocode is meant for another human being for reading and interpreting that code, so that the other human being can interpret that code in a programming language. Here is an example of a pseudocode. This is just human readable language using Estonian words. Of course, this pseudocode is not understandable for any human beings. It's quite limited. Instead of this, we could use what? Symbols, pictures, small pictures. Although they can also be interpreted differently. But this here is not meant for programming, this is just for planning for humans, otherwise, anyway, not for machines. And here we see that for every step there is a common part. If there is in the calendar, we can take it out. This is a common part, and then every step out of those 3 steps will be shorter. As I can use this algorithm for preparing every school day or any school day, this is general enough. There is an input, there is an output, there are steps I have to follow. No next step can be taken before the previous step. It's stepped and it is final. I always come to a result. Next part. Algorithm. What is an algorithm? Do you remember from the last part? I gave a definition for that. Order of commands. But what's the difference between a program and an algorithm? Program can be executed. An algorithm must be either written into a program first, or if it is meant for human beings, it can be executed right away. Like for planning a party, there are no machines involved, so it can be executed directly. But otherwise, it is just a plan for a program. Sometimes you have to research existing algorithms, sometimes you have to create new ones for solving some problems in life. There are algorithms for different situations. For instance, finding the shortest path, or for sorting, or for searching. The more you know different algorithms, the easier it is for you to solve different problems in life. For instance, earlier, I had many books. I still have many books at home. I have no time for reading them. But I wanted to put them alphabetically to bookshelves. Let's imagine I have 20 books here on the shelf. They are sorted alphabetically, and I have to add a new book. How do you know where to put that new book so that the list remains sorted? How do you find the previous book? I want the list to be sorted alphabetically. I have a book for every letter, and the new book has the letter N. It is there already. The shelf is full, and I only have to have a new book. I have to find where is the book M and where is the book O. But how do I do that? Then I try to write down the list of bands, but I did it manually without using a computer, so I just couldn't sort them. And I decided to create a paper for every first letter. So then if I got a new band name, for instance, I don't know, Vanilla Ninja, then I just took the paper with V and looked whether there is Vanilla Ninja already or not. Then I wanted to create a database for music, because I had music on different storages. I had music cassettes. Do you have music cassettes? Then I had CDs, MP3s. Then I decided to create a database so that if I enter a song name, then I see where it is, in what storage. Then, as I wanted to go to Romania, I wanted to spend some days after a conference while discovering that country, and I needed to plan for that. So I made a plan, an algorithm again, which transport means use, how much does it cost, and when does it go, and so on. And then I started to arrange tennis competitions. For those I also had to create a new algorithm because I wanted to make a perfect draw so that the result is a list of players that is sorted according to their real levels. And then I decided to do it according to the algorithm of merge sorting. And last year I created two programs for that, one in JavaScript, another one in PHP, and there is also an algorithm for that. Then there is a diagram for how to protect your home, I think, if somebody tries to steal it. And if you follow the diagram, usually it should work, but even those attackers do not follow their own rules. Then they ask for a K command and try to steal your home from you anyway. And if you learn something, before you can learn something more complicated, you have to learn something, some prerequisites for that. Or if you want to replace inside of text a word by another word, then you have to go through all the occasions with that word, and that way you can replace those words. An algorithm again. There is an algorithm for finding the biggest number out of the given number. In JavaScript it's called max, and for finding the smallest number there is a function called min implemented according to the algorithm for finding the smallest number. But you cannot always use those functions. Let's say you are in a forest and there are people with different amounts of food, and you have to find who has the most of food. How to do that? You just cannot push a button to find it out. You have to use an algorithm for that. Even if that algorithm says most probable, it is Martin.